Hello? Can you hear me now?
Yep. So,
Is it working?
give it 30 seconds.
Okay, I couldn't tell if my camera was working or not, but
Your camera's working.
yay.
I think apparently you're good.
Thank you guys. I'm sorry. I take a while to like go back and forth between doing stuff. I guess I'll just start over. I don't know where I lost my sound connection stuff. So, do you know when I lost my voice? Was it like from the start? I never had sound. Great. Okay, I guess I'll just start all over. It's okay. Um, where are my slides? Okay, starting all over. Thank you for your patience with me having technical problems. I am so sorry. I'm still new to streaming world. This is my second time streaming, so I am so sorry, and thank you so much for coming to watch this video, and hopefully you get to learn a bit of SolidWorks and how to use it. Today will be a continuation of what we did last week, which was, well, last week we made parts for Trammel of Archimedes, and today we will make an assembly of the parts we made and also make a drawing of the part and the assembly we'll make. And I'll also touch a bit about GrabCAD, which is the software we use, and excuse me, and also couple other things, tips and tricks with SolidWorks. And I have slides available for assembly part of this tutorial, but I do not for drawings, unfortunately. I figured for today I'll just go over, like, I will just show you how I would do the drawings based on my experience, and maybe make another tutorial or make a slide or prepare the slides based on the feedback I might get from today's tutorial. So hopefully that's okay with you guys, and we'll just get started. So from the last tutorial, I've asked you to, well, we've ended here. I've given you basic dimension of this handle that we need to make. And I was expecting that everyone would make this before today's tutorial. And today before we start with the assembly part, I'll just, I guess, show you how I would make this handle. So this is a new part that I started working on. You might have watched me, I guess. New part. I started with boss. The function I'm using is slot, and just a straight slot. And I'm just gonna, I guess, just make one, random one. And I don't know why there's a coincident. I don't know what's coincident. Or maybe it's coincident like in terms of where it's like longitudinally. But I'm just gonna delete that because what I want is the center of my slot to be mated with the center of the origin, or the origin. And so this basically looks like how it looks here. What you could have done is like making a rectangular handle and then put a fillet there, but I think this is simpler for the shape that's shown there. But I guess you could get more creative with what kind of shape you want of your handle, but I'm going simple. I'm making holes here. So another thing is you could have just like made a base and then like drill holes there, like with another sketch and another function. But since this is just like a simple part. I'm just doing as little as possible by just like putting the holes there already. I'm gonna make these equal because they're supposed to be equal radius, and I'm gonna set a diameter of one of them to be 10, and it should set both of them there. And I'm gonna set the dimension with our width, which is 30 millimeters, and the center of this hole to the other hole, which should be 100 millimeters. And now my sketch is fully defined, so I'm gonna exit my sketch and extrude boss my sketch. And the height of this handle is also 10, so I'm all good. Okay. And I also need where I will put the, I guess, handle knob thingy. So I'm gonna select the top of the boss that I just made. Control 8 to see it on top view, or like lock it to that view. And I'm gonna sketch on that plane of my boss. And all I need is just like a circle, so I'm just gonna make a circle here, and I want this, like the center of my circle, to be concentric to this circular like half circle. So I'm just gonna kind of like hover over and then look for that. Or I guess I could also just select these two and then make them vertical. And also, or actually another thing I could have done is selecting this circle and that half circle and then make them concentric. And I'm gonna set the dimension of this, and here we have 15 millimeters. And now my sketch is now black, fully defined. So I'm gonna exit my sketch. And I'm gonna do another extruded boss. And handle height is 20 millimeters. 20. Done. I could end it here, but as it's shown here, I might add some fillet. Or actually, I guess I'll put fillet right there. Like if I were to 3D print this, for example, like if I only have just like one like extruded part without a fillet, that part would break very easily if I'm using FDM 3D printer. So I'm just gonna add some fillet there. I put 3 millimeters, but you could put it in different dimensions if you want smaller or bigger. I guess I could also put 5 if I want it to go all the way there, but not a big, I mean not too critical. Wait, that doesn't look like 20 millimeters. Oh, that is 20 millimeters. Okay. Oh, what? Okay, the drawing and the slides are a bit different. I think the handle height is supposed to be 30 actually, so I'm sorry for that discrepancy on the slides, but the height of this handle is supposed to be 30. I mean, I guess it doesn't really matter because it's just something you hold on to, and I guess it could be shorter, but anyways, I'm gonna save this into my folder. I'm gonna call this handle. Saved. And now we can move on to our main part of the workshop. Let's see. So the learning objective of today is after this tutorial, you should know how to use GrabCAD Workspace, create SolidWorks assembly with mates, and you'll be able to make some drawings, and you'll learn how to use templates. Disclaimer again, similar to last week, I don't work for SolidWorks or certified, by them, and you will not become an expert in all things SolidWorks after listening to me for another 2 hours. I'm sorry, but hopefully you'll gain some more knowledge, and hopefully you'll be more comfortable with the software. The assembly portion of the slides were originally created by our captain in 2016, Simon Honigman. So some captures might be a bit different, but most of the function we use is pretty identical to 4 years ago. And the drafting / drawing portion of the slides are adapted from MEC 220 notes written by our instructor Marcus Spengler. I've adapted some of the stuff that I've learned during MEC 2, and I hope that our team members get to know about those knowledge as well. So I've added some of those contents there as well. So hopefully it doesn't become too dry, but also helpful. Format is similar to same as last week. Walkthrough here on YouTube, and if you need any help, we have our lovely volunteers online at the moment. There are about 5 of them online. Thank you again, our volunteers, to take your time to help our members. Link to slides are here, tinyurl.com/subc-software part 2. Oh, I just noticed my slides weren't showing. I am so sorry. Okay, there we go. Oh, I'm so sorry. You didn't really need slides for those anyways. But if you want to look at the slides, I'm gonna put the link to the chat right now, tinyurl.com/subc-solidwork part 2. So you can look at the slides. Yeah. So GrabCAD. I should share my screen. So 1 second. Display capture. So I believe your team leads should have talked about GrabCAD, mentioned GrabCAD, or given you access to our GrabCAD Workbench area. I'm just gonna go through like an overview of SolidWorks Workbench. It's a file storage. It's almost like a GitHub for our SolidWorks stuff. You should have gotten access from your team leads. If not, ask your team leads. Our SolidWorks files and models go in here. You could also add like other files like Excel spreadsheet or like some documentation about how to make this specific part. Like you can put all sorts of parts in there or files in there, but if those are the files you want to share with the team, I would recommend you to put them in the drive in the right folder. And yeah, as it's written here as well, use the right folders and try to keep it organized. I guess I should go on to it. GrabCAD.com and Workbench. I'll log in here. Okay. And when you go in here, you should be able to see all the project updates. But if you click File, there are folders for our projects so far. What else is covered here? Oh, if you need to upload something, you can click Upload Files and like find the file from your folder. From your hardware and upload. And it says describe your upload, and it'll be uploaded. And what happens when you click it? you should be able to see the, let's see, let's look at our full assembly. So when you click on it, you should be able to see like a preview of the file, at least for the ones that we've made last year. I believe GrabCAD hasn't updated their system yet to be able to show or like render the SolidWorks 2020 parts, but at least we're able to see. Oh dear goodness. Okay. Anyways, this is how you can just like look at our model without going into like opening SolidWorks on your computer. If you want to get like a brief measurement, you can like, I guess you can do a exploded view if we have like the whole thing. Whoa, we can do an exploded view to see like the insides of an assembly. You could do a section view to see the inside. We could also measure, like, say I want to measure the length of our wing. I would why can't I? Whoa. Okay, I'm not gonna spend too much time into doing this, but you can measure things. So, and the question here is, what happens if we upload a file with the same name as like the file that already existed? Then it'll ask you like if you should update the file to a new version, and yes, you would update it to a new version to overwrite, and it'll show that it's a new version. It'll show v2, and when you click on the version number, it should be able to see. You should be able to see like the different versions. If you want, you could go back to different version or restore to that like older version if like the new version you uploaded is something wrong. So very helpful tool. Why I'm not familiar with the web version of GrabCAD is because I use the desktop app version of Workspace. So hopefully you do have access to, I mean, maybe you've gotten to download it, but it looks like this, and you can go into our GrabCAD folder, and this is where you can find basically the same thing as what we've seen earlier with like all our projects. So yeah, since I'm guessing most of us haven't done that yet, and if you haven't been to our workshop last week and haven't made those parts yet, I've already pushed all the parts that I've made ahead of time here. So you could select all of these and download all into your, oh, interesting. Okay. Anyways, you could download all of these files into your system and start working on today's workshop if you'd like. So yeah, that's a brief overview of our GrabCAD space. And now on to SolidWorks, the assembly. So, 1 second. Okay. Coming together right now. Let's do this. So, same thing. Hit new, assembly. Okay. to begin assembly, like when you like open the assembly, you should like this will show to begin assembly, and I'll browse for my base part because that's like the core part of our assembly. So I'm gonna select that, and it'll like show a preview here, and I'm just gonna click, and it'll just like be placed in our assembly space. And we'll wait, what does our slide say? Oh yeah, basically what I just said. When the first part you put in our assembly space is the fixed part, so that this can be like the reference point of the other parts that you add to. But if you happen to add like other parts first, and if you want another part to be the base part of your assembly, you could right click this and then make it float so that this is not mated to anything. But for today's assembly, we want this to be our fixed component. So yeah, next one. So we're gonna add our nut first. So insert components. It was right here, assembly, and then insert components, and browse. Or if you already have it as open, it should just like show there. And we're gonna put our track nut in there, open, and it'll just kind of like show here. And we're gonna do a mate. So when we say mate, is basically assigning like some sort of a reference, like setting a reference between like one part to another. So what we'll do first is to select the face of the nut. Oh, another thing I realized I should have mentioned last week is how I navigate through here. It's definitely nice if you have a mouse. It's not nice if you have only your trackpad, because you need the middle button, middle click button of your mouse, because that's how I rotate my part. I rotate by clicking my middle button, or like the scroll button, and I use my right click to like for like a shortcut of like, if you're not doing anything, like if you're not in a sketch, like in like a plain space, your right click button will have these like a shortcut to like all the sides, and left click is to like select as usual. Oh, another thing that might be helpful is if you hold on to control. Oh, that's not what I wanted. Maybe not control. Is it shift? Shift. Oh, okay. It's control and middle click to like pan through the space. So like say like your part like is there and I wanna see it, and then I would like hold on to my control key and my middle button. So yeah, anyways, back to our mating. So I'm gonna rotate so that I can see the bottom of my nut, and I want it to be mated with like the surface of our channel. So I'm gonna select that surface. It should highlight, and I'm gonna click mate. And usually they would automatically select whichever mate that makes sense to SolidWorks, and it usually happens to be coincident, and that's all we needed. So I'm gonna select coincident, and now we'll do a advanced mate. So when I say advanced mate, basically what we want to do is we want to move this nut from here to here, like along the channel. Like we want to be able to move it back and forth like this. usually when you do regular mate, so like for example, like I made that plane to that face, like the side face to the side of our base, and if we do coincident, like it will mate. It just means like it'll be fixed to this surface, but that's not what we want. What we want is to like, wait, I think I should have added another mate. Oh, maybe the bottom face wasn't the mate I want to do. So I'm going to select back there, and I think I should have done this. So like the side of a channel and side of my nut, so that that's mated. Okay, so it's already constrained in that, and I'm gonna do a advanced mate of width, and I want it to be free between the width, and I'm gonna select my width is from the one side to another of my base plate, and my tab is one side to another of my screw. And now it should be, oh good, no, not all good, okay. Oh, it's supposed to be free. Why? I don't know why that got unselected. Okay, I do need the bottom mate. I guess it's missing from our slides. I'm sorry. There we go. Now you can move things around, and I can't move it anywhere else but within the two sides of our track. So there's that. And then what else do we want? So hopefully that was clear, and I want to see if anyone has any question. Nope. So I'm gonna move on to the next slide. Now we're gonna add a screw. So I'm gonna close this, insert components, screw. I already have screw opened, so I'm gonna just do that. And as I mentioned even during the last week's tutorial, screw, like the thread, take up a lot of computing power, or like not a lot of computing power, but like if you have a lot of the same screw or with the thread, it will take up computing power. So I'm just gonna make that hidden. Oh, not the part hidden. Show. Well, I'm gonna go edit my part to hide the thread. Suppress. There we go. Sorry, suppressing is like just like disabling that function, but it'll still exist in the file. I just want to suppress it so that it doesn't take up too much of my computing power. So now my screw is clean. Oh. And SolidWorks will be like, something changed. Do you wanna rebuild? I usually say yes, unless like there's like if it's a change that's not as important. Anyways, we're gonna do two mates for the screw and the nut. So we're gonna do concentric mate. So with the circular part of your screw, head and your thread section are concentric anyway, so you can select either. And then I'm gonna select the top edge of my nut by holding on to control, and usually like this should pop up so that you don't have to go into mate, but yeah. And I like to lock rotation unless like it's a part or it's a mate that it needs to rotate, but I usually lock rotation because I don't really need to show that the screw rotates around a nut. And another thing I want to do is to do a distance between these two. to be 10 millimeters. So we did coincident before. This time we're gonna do distance, and it's gonna be 10 millimeters because that's the thickness of the handle we made. So selected, done, and the next one we have to do is, now we have to do the arm. Oh, they called it an arm. I called it a handle. Same thing, some name. So I'm gonna add it there, somewhere here, and I'm gonna make our screw and nut assembly onto this hole. So I selected the surfaces and I can make them concentric. And I want the top surface of our arm or handle to be coincident with the bottom of the screw head. So I selected those two and it pops like coincident, so I'm gonna hit coincident. And when I do Control 7 to see this in isometric view, now I can see that my handle arm is mated properly with my screw and the nut. And I can also rotate this too, and I can move our channel around. Alright, so it looks like something's missing here, right? And if you think that way, that is correct. We are missing a screw and a nut to go into another hole. So there are two ways to do this. One is to just do the same thing I've done so far, to insert components, go do the screw and the nut. But what might be faster is to do a copy with mate, to use a copy with mates function. So I'm going to select my track nut and screw part, and I'm going to right click, and I'm going to click on copy with mates. And so just double check these are the components you want to copy, and you can just hit next. And it's asking select a new reference for each mate. So you should be able to see what mates are which, or like you would kind of remember which mates are which. So, or you can also like hover over your design tree, and if you hover over here, it shows that it's the wall of the nut and wall of. So the orange preview is like the part from the part you're copying, and the purple is the part that you should select. So we wanna mate it to the channel on the other side. So I'm gonna make it coincident to this side. And for the width, again, it shows the previews of orange and purple. Earlier it was between these two sides, and for the new nut, here now you kind of see like the preview of our new copies. Anyways, for the new width, we want to be these two sides, and coincident 3 is between the bottom of my nut and the surface of our channel, and it's the same thing. So I'm just gonna check repeat. Over define. What happened? Oh. Maybe I don't need it. Concentric to be same over here. Oh, a conflict. I'm just gonna. If all went well, you would have been okay with like just selecting all the stuff, but I'm gonna go troubleshoot my part. I don't know where this has made it to. Oh, I think I know. I think I selected the wrong side. Okay, I'm gonna start over the copy with mates then. Next, I'm gonna do this side this time. Okay, and then width was here and here. That's weird. What is happening? Nope, I want it to be the other way around. Coincident to be same. Concentric around my center point of my handle. And coincident to be the same. So I'm just gonna hit OK and I'm gonna deal with my errors now. Okay, selected that face, and it's not that face we wanted to select. We want to select that face. And I'm gonna flip it. Oh, SolidWorks is not liking me today. I'm gonna try number 3 of copying with mates. Hopefully it worked for you guys. I'm gonna try the other mates first. I'm gonna do these two. And that should be a repeat. Yep. And for concentric, it's that one. Coincident should be the same. Alright, let's see what happened here. I didn't put all the mates, so it's not gonna have all the mates. Oh, I need to make these two because that I'm gonna just do them now because earlier it was giving me errors and I couldn't figure out from that copy with mates property, so I just added them outside. And now it should be fully mated. Yeah, that's the elliptoid that we wanted to see. So if you want to see this from the top, and zoom out a bit, and when you rotate the handle, you'll be basically the handlebar is moving in an elliptical motion. So yeah, if your part moves like this, you've succeeded in successfully making an assembly here. Pack and go. So pack and go is a function that you would use if you are going to send an assembly file to another person. But when you do that, you can't just go into your folder and just send a assembly file to another person because it's not containing any of the part files. What you want to do is you want to pack and go so that the file you're sending to another person has both assembly but also the parts. So you can find that here, file and then pack and go. And when you do that, oh, I should have saved my assembly file first. Rebuild and save document, and it's gonna be thermal Archimedes assembly. Now we're gonna pack and go, and it'll show like the parts file names. If you don't want to select a part file for some reason, you can select those as well. And you can save to a folder, so that it's just like a folder, or you can save to a zip file. When I usually send to another person, I usually like to do save to zip file. And you can have like different structures. I usually like to do full folder structure just in case I have like my own organization of parts going on. But you could also do flatten to minimal folders or a single folder. So if you hit save, it'll do its operation and pack and make your part ready to go. So yeah, that's it for the assembly portion. And now we're gonna go into drawing. Unless anyone have any questions. I'm gonna check Discord as well. And I'm also gonna grab some water. I'll be back. And I'm back. Alright. I haven't seen any questions yet, so I will move on to the next part. So drawings. So this is what I mentioned. I've grabbed some stuff from my notes from Mech 2. Drawings, I felt like it's an important topic to cover, especially for this year, because we don't have access to machine shop at the moment, and I'm not positive if we will anytime soon. So drawing becomes especially important because I'm sorry. Drawing becomes especially important because we might have to send drawings of our parts to external sponsor or a machinist to make a part for us. And since drafting is a language of pictures, symbols, and conventions that communicate specifications using graphics in standardized art arrangement, if we don't have proper drawings drawn and sent to our machinist that we might have, or like a sponsor we might have, like we might not get the part that we asked for or we imagined we would get, or it might lead to a longer lead time of when we could receive the part that will be machined. There are several drafting standards for drawings, CSA, ANSI, ISO. I think we usually go for either ANSI or ISO. I'm more familiar with ISO, so I think that's the standard we usually go for. I'll double check this for the next time. Anyways, as I mentioned earlier, we as engineers, we need to be able to present and communicate ideas in the same language as the people who are going to help us or approve and make our design. So that's why this becomes extra important for this year, I believe. There are different ways to do drawings. I believe this might be covered during AFSI 100 class. Maybe not when you go into like isometric views and all that, all the drawings. I don't know if they still do it or not. Anyways, there are two ways to do this. There's third angle projection and first angle projection, and it's just basically like how you show the part, like at which angle. So for the third angle projection, the object is placed in the third quadrant, and first angle projection is in first quadrant. We usually use third projection, as the slide says. It's usually widely used in the United States, and since we are in North Americas, we use third angle projection more. But in other parts of the world, apparently they use first angle projection. They prefer first angle projection. So that's just an FYI. Okay, so that's about it for the slides. So now I'm just going to show you how I would do the drawings and some other parts or like functions of SolidWorks that I believe you should know. So I'm gonna change my settings again. There we go. Okay, so to start with the drawing, we'll do drawings of the parts first and then the assembly. To do that, as always, new drawing, okay, and I'll bring this up, and I'm just gonna close that a bit real quick. So when you first open your drawing, it won't look like this. It'll look like a generic SolidWorks sheet template, but I've set my workspace to use SUBC templates, and how I did it was by going into my systems options, and hope you can see it. Let me know if you can't see like these tiny letters on my screen, then I'll try to find a way to. Oh my. Okay, I'm sorry. I didn't realize my screen wasn't being shared. Anyways, let me know if you can't see these tiny letters. I think you should be able to. There's a delay between like what I see and like what's actually happening on YouTube, so I'm sorry if I'm like staggering for a bit. That's because I'm waiting for responses on Discord or the chat. Anyways, I don't see any comment here, so I'm just gonna move on. Anyways, what I would do is I would go into default templates. No, actually, I would go into file locations, and I would set my document templates folder to be, so like here, like it'll show like the default template for like what SolidWorks has. I guess I could reset it. Yeah, it'll show like the default templates that SolidWorks has, but I'm gonna add our SUBC. And our SolidWorks templates are all located in the GrabCAD folder. This is why I would like why it would be easier if you have GrabCAD desktop version, so that you can easily manage like all the what's the word? So you can like easily get stuff from our folder rather than going into browser, downloading, extracting it, and like putting it to your right folder. So onto our SolidWorks templates. There are several different templates here. The one we're looking for at the moment is document templates. So I'm going to double click that and select folder. And I'm going to move it up because this is the primary folder I want to use. Another thing you might want to do is to go into BOM templates and add our BOM template there. Move it up as well. You don't have to, but it's just like I'd like, if you're working on a SolidWorks part for SUBC, it would be beneficial for the team to have everyone to use the same format. That's why I ask everyone to use this. Another thing I think what other templates are there? Let's see. Sheet format. Add sheet format. So just set like all your like file locations to also look into our SUBC folder as well. And what's the other one? Revision table. Revision table templates. So we've made these templates were made like a while back. And I might potentially update this as I find needs for it. So this is why again I was instead of downloading it to your folder, to your system and like updating it manually, I would just refer to my GrabCAD folder, and you can like find your GrabCAD folder by like going into that like I have it in my documents and then GrabCAD. So like I can just like Control C this and then Control V here, and like I can easily find my templates this way. So that's what I would do. Any other templates I think is important? No, I think that's about it for custom property files. We're not gonna get into custom properties today, just because today's workshop is supposed to be very introductory, but I'm just gonna put it there just for future, and this will be updated definitely. So yeah, that's about it. SolidWorks will warn you, are you sure? And I'm gonna say yes. It'll do like a request. And you might still not see it. If you don't, what you can do is right click on Sheets on the left and hit Properties, and in the sheet format size you should be able to see all the formats that are available that are standard. And somewhere here you should be able to see our like our own template, SUBC template. And what we'll do, since we're making a part, I'm gonna select SUBC part metric. Our part is a metric, so metric letter size. We've made only letter size only, but if we think it's needed, I might add more standardized size into this as well. Anyways, for the time being today, I'm gonna select the letter size, metric, landscape, and apply changes. And ta-da! You should have your SUBC sheet format. Now we're gonna add parts into here. So I'm gonna click on model view and I'm gonna look for my part. I wanna start with my base. And there are different views you can start with. And I believe for this particular part is that I'm gonna hit preview. To be able to see the top of my trammel is the most important view. So I'm gonna select that. Oops, sorry. I'm gonna select the top view and so it should show a preview. And when I click here, it'll be placed here. And before you like hit escape or something, you should be able to like drag it up or right or down. I guess it makes sense to drag it down and maybe also to the right side. And right now my scale is custom 1:5, but I think I want it to be maybe 1:4. Yeah, that looks better in this letter size. And I'm gonna now do dimensions. So what you can do is we can go into sketch, annotation, and you can hit model items. So this model items really depend on how you've done the dimension, or like how you've set the dimensions of your part when you were making the part. Entire model, all views. Oh, I guess that's it. And all the other things are not showing. I'm gonna try doing this again. All views, entire model. Boom. So now you can see it shows that the size of the length of one side of our base, and since it's square, to show that it's square, you can put dimensions on top like this, or also you can say that this is a square. So on the left side, you can like add some stuff to your dimensions. And what I'm gonna do is I'm gonna say this is a square part. Oh, okay then. Apparently something's missing still. Tools, options, file locations of symbol library file. What is there? What? Well, I can work on that later. So that's what I would do, to put a square there, just to show that this side and that side is the same. And as I mentioned earlier, how you made the model will also show in your drawings as well if you use that like the model items function, which is a very useful function to use. And since I made like half of my trapezoid and then like mirrored it, this is why it's showing it like this. But this is not like we could leave our drawing to be like this, but this might not be clear for our machinist or like someone who needs to measure to make sure that this part is accurate. So what I would do is actually to get rid of all these dimensions, well, the height is okay, and I would actually show the distance between these two and between these two, and the height from there to the base. So I guess I could have left that 17 there. But yeah, this is what I would do. Also, the best practice is that you put the dimensions all together. On the inside of the models rather than the outside. Guess I could have made that if I'm gonna put my dimension on the right, I'm gonna set my reference to be there. I guess over here. So that like there's a gap between those two. Like technically I could do it like this as well, but then like the dimensions kind of get confusing, so that's why I put it on the bottom here. There's also like standards about like how far your dimensions should be off of your part and all that stuff, but I can't remember on top of my head, so if you're curious you can also check it out like Google it, look it up. I think there's another thing I wanted to do here. Oh, I mean, also like for the other side, they're the same dimension. So instead of putting the same dimensions on this side as well, this side view, I would just put a note that like the dimensions are like, well, the base plate is a square and the channel profile is the same in both sides. And usually, I guess it's different depending on where you go, but usually you could also like attach like a 3D model of your part in the file you send to your manufacturer. But if this is being like CNC'd, but if you really want, I guess you could also put an isometric view of your part as well. But I remember during my co-op, my supervisor was like, why would you add another part that you're not adding any meaning to? So this is like if you don't trust that the person won't recognize how your part will look like. But I think this is pretty straightforward, that like this is a square base with like the trapezoidal slots on the center, crossing the center of my base. I'm gonna build and save. Oh. Huh. Apparently I was editing the drawing. Okay, I'm not gonna save this because that's gonna overwrite the template, but that shouldn't have happened. Whoops. How did that happen? Maybe I should have done save as, so that I don't. Yeah, I should have done save as. Well, I've already deleted the drawing that I just worked on, so I guess you guys can go back into the video if you wanna see what I did earlier. But yeah, you can do the same thing for rest of the parts that we've made so far. Usually you wouldn't really need to do a drawing for a screw because screws are all standardized, or at least the screws that we use are standardized, so I wouldn't make a drawing for that. Let's make a drawing for a handle. So this time what I used was standard 3 view, which will just like do the front, right, and top. Let's see. I want my skip to be a bit bigger because our part is pretty small. There we go. And we're gonna start dimensioning these. Put into all views. And there we go. So I would move this dimension here so that it's on the inside. I'm gonna move the reference point of my dimensions to this side so that there's like a tiny gap between the part and the dimensions that I'm making. But these are just like really minor details. And here it shows the diameter of our handle and the hole. I guess we could do another dimensioning for this guy as well. Also, instead of mod diameter, like it should show this diameter symbol, but apparently my symbol library is missing, so I'm gonna go fix that later. But it should show like just the diameter symbol. And I guess it would be worth putting the dimension of like the overall dimension. So I'm gonna put 200 there as well. Actually, did I need to? Yeah. Also, what you want to avoid is putting multiple dimensions or like a dimension that could have been derived. So like I could like put dimensions like this, but these, like if I didn't have this dimension, you totally could have derived that the distance between this hole to my handle is 100 millimeters. So that's why I usually wouldn't. I mean, you're not supposed to put multiple dimensions unless like that's a critical dimension that you need to measure later, or if it's if it's just a dimension that you think it's important. And in that case, that inevitable case that you have to put another, like the same redundant dimension, what I would do is to put it there, but put it in brackets so that it's like as a reference, but not like something that is as important, or like that's so that it's like something that you don't have to do mental math. I'm just gonna delete that. We know the height and we know the width of our thing. So this is like another funky thing here. Since we're using CAD, it's gonna like try to automatically put our arrows here, but like there's like a duplicate of arrows that like it's hard to know which is which. So what you could do is you could like move these numbers around so that like it looks like this, or you could also go into leaders on the left and you can set like which side you want to put your arrows. So I want it to be this way. So boom. Maybe I'll put it like this. And R3 is just showing that fill size. Am I missing any other information? Nope, I don't think so. So this is another drawing almost done. Let's see. Other things I guess is worth mentioning to double check is units. In our case, it was metric, so just clarifying that we're using millimeters here. All these other stuff are actually they all come from properties, which I'll briefly go over soon. And also, unless otherwise specified, dimensions are in millimeters, and they use as tolerances. So if it doesn't have decimal, so for all of our parts at the moment, since it doesn't have decimal, our tolerance is plus minus 1 millimeter. So that's meaning like our like thickness could be 11 millimeters or 9 millimeters. And one place decimal will be 0.1, and two place decimal will be 0.005. And how you could potentially, because it says unless otherwise specified. So to specify the tolerance, you would go on your left side, and you can set different tolerances. So basic is like top and bottom. I think I wanna do. That's a limit. No. Okay, so you could do limit. So you can set like upper limit. So like say I want this to be like as big as only 0.5 and 9.5. Whoa, sorry. Or so that's like a limit way of doing it, but this could personally confuse me. So what I usually like to use is bilateral, so it shows like plus minus 0.5. You could also set min or max. So in the tolerance modifier, you can set like say like 9 millimeters min or max. Well, in max case, like I want this to be only as tall as 10.5, and that's how you would set it usually. What else? Material and finish. So material, in the previous or last week's tutorial, we've set material to our part. I didn't do it for this one yet, but and then it'll like automatically show here once we've went through the properties. And for finish, you can like select different finishes to your part. So it could be just like get rid of deburrings so that you don't cut yourself. So, or you could ask them to like sand it out so that the surface becomes like really like nice and smooth. Or you could just ask them just like no surface finishing required. And since we are working in different subteams, this will show different subteams we're in and the submarine name that we're working on at the moment. Let's try to set properties of this actually. Open part. And on the side here, since we've already like set the property folder in the settings file locations earlier, we already have the custom properties set for our part. This is revision number 0. We're gonna make this part. We're not gonna buy these or modify already existing part, so I'm gonna just leave it at make. Part name is tremel arm. Part number is part number, tune in. We're still working on organizing that. We're trying to set like a proper part name, part numbers organization, so tune in to find that out. In the description, arm for elliptoid. Wait, I think the lithograph. I think that's the name of this. This is not a water jet part. I want our surface finish to be smooth. Submarine. As I said, this will be updated. So for now, I'm just gonna choose Skookum Chuck Mark 6. At the moment, there are only 2. I'm just gonna put it a frame. Author, my name, so JSO. Drawn date, it was today, and checked by. So this will be if your team lead will check your part. Let's say ABC checked my part, so I'm gonna put it there. And so this will be done by your team lead, or I guess someone higher up. And they'll check your file that it looks good, and like if this needs to go into a production, and they'll like set the check date to be something, but we're not doing that right now because no one's checking my part, so I'm gonna apply that. Build this, save this, and go to my drawing. And if I rebuild this, boom! Now it shows water jet cutting now. Material not specified because I haven't set my material yet. Finish is smooth. Subteam frame, submarine is Skookum Chuck Mark 6. Since I didn't set my material yet, it'll show my density is 0 and dry mass is 7. 1 grams somehow, since even though I haven't set the, maybe it's calculating error. Anyways, but yeah, and it shows the number and rev 0. Oh, size L means size letter. So yeah, this is like very basics of doing drawings, and some more standards are coming, so tune in and I'll do another workshop on that when it comes to it. So save and tremolo arm drawing. So yeah, that's it for that part drawing, and now on to our assembly drawing. Before we do the actually, let's get started with the assembly drawing, and I'll move on to what I wanted to talk about. So since we're working on assembly, I'm gonna go into the properties and set it to be assembly drawing metric still. What changes? And it should change the format a bit. Yeah, so now you can see like the water jet part stuff is gone and the material stuff is gone. And it looks like I have more space, sort of. So you could have like clicked these ones, but you could also do is on your right side in this toolbar thingy, I can click view palette, and this is only possible if you already have the part open. And if you hit refresh, like it'll show the part that you've made already. So for the assembly drawing, why you want to create this is probably because you want to show what parts are being used in this assembly and how they're being assembled. Doesn't have to, I guess it could be step by step, but it could also be just to show how things are put together. Let's see. So you could put like just your assembly view like this, but what you could also do is to show exploded view. So I'm gonna right click and then open assembly to edit my assembly, and I'm gonna do an exploded view of my assembly. So I'm gonna click that, and now we're gonna start exploding our part. So for this assembly, how would we assemble this? The screws will come last, right? So I'm gonna select those, pull this up, and I'm also gonna bring our an S step, and then pull this up, done. And these screws actually come from the screw actually come from the sides, right? So I'm gonna do that, and done, and I'm gonna do this. So you would usually explode it to the direction that you would insert your part into another part, not like just like explode it only vertically or explode it only horizontally. So this roughly looks good to me, but another thing that's like doesn't look right is because I don't know where this screw is actually going into, or like which direction my nuts would go into. To help with that, you can do a explode line sketch. So I'm going to click on this, and I could connect my thread surface to my hole on the arm. Then it'll like create that line. Do the same for the other one. Sometimes they'll like do weird things with the lines, with the directions. Then like you can just click on that arrow again to like change the direction. Hit OK. And I guess it will be good to also select like where this goes into, let's say here. No, that doesn't look right. No. I would maybe put a plane there actually. Select the plane of my base. Oh, what's happening? Base to here. Huh, I'm not sure what's happening there. Well, right now my base isn't about my origin, that's why it keeps showing that origin. Okay. I guess just for the show, I could show how I could have my whole assembly about origin. So earlier I mentioned about like fixing and floating our part. So I made this float, and what I'm gonna do is I'm gonna make right plane of my assembly space to mate with the right plane of my Tremel base part. Mate. Yeah, and then also mate to the front plane and the top plane. So this is like if you really want like everything to be fixed about like the plane of your assembly, or like the space in your assembly. But this is not necessary because everything will be about the first part that you put in. Now I'm gonna fix this. Looks like I'm gonna have to explode this again. Or if your part is unexploded, you can go into configurations here and then select this and then explode. And now you can see the explode the view again that I made earlier. I'm gonna go into isometric view again, and yeah, sure, that looks good. I guess I could try to draw that line sketch again, but we'll see how that goes. Does it even show preview? Okay, I guess not. Well, okay, 7, and go back to my drawing, and when you click on right side again, and if you hit refresh, it'll show the isometric exploded view here. Boom. So I guess 1.125 is too small, so I'm gonna do that. So if you want to, you can get rid of this. I don't think it's necessary to do that anyways. It's here. And what you would do is you would I guess let's add table of bill of materials first. You would do labels, bill of materials, select the assembly view for the template. Select, and I'll show this. And as you can see here, it shows the just general numbering and part number. So in our case, just like the part name, or like the file name, part file name, and it shows the quantity. So like we need 1 of the base, 2 of the nut, 2 of the screws, and 1 of the handle. And what you can also do is you can do, actually, let's do auto balloon. And it'll show like, it'll show or label the parts like that. And what else? I guess we also want these available as well, so we're gonna go back to our assembly file and do the everything again. Assembly name, Tremel of Archimedes, assembly number to be set in the future, made for workshop, sub-team, submarine, already mentioned earlier, all over. Author, me, I made it today, so I'm going to set it to be like this and apply. And when I go back, it should all, when I build, so Control B or do that, and it should automatically update all of these. 001, 0101, Tremel of Archimedes. This looks good, and this is good enough for me, I think. I mean, eventually you might have to like add notes of like if you have any specific notes, but this itself already shows like what parts are being used and how, like, rough estimate of how things might look and such. So yeah, I think that covers everything that I wanted to talk about today. Unless there's any questions from our crowd. Update view. I think I accidentally set my template, or like set myself to edit the template for some reason, so I'm gonna fix that. But hope that doesn't happen for you. If it does, you save as instead of writing over our SolidWorks template. FYI. Tremel of Archimedes assembly drawing. Done. Alright, let's go back to our slide now. So yeah, that's about it as like a intro to SolidWorks of how to make parts, how to make drawings, how to make assemblies, and hopefully that was enough for you to kind of get started and get familiar with SolidWorks and kind of be less scared about how to use SolidWorks. And next steps, if you're interested, or maybe you're already working on this, but you could try to do modeling with complex curvatures. So maybe you can try to model a dog. I know Andrew's trying to do that. We could do motion studies and animations. So like the elliptograph that we've made already, you could let's unexplode this or collapse this, and you could like do a motion study and like make an animation of this rotating. So that's another fun thing you could do. You could do finite element analysis (FEA) on SolidWorks, and so much more. There are a lot of tutorials available on YouTube already. Or you could also just go back to some of our part files from before and maybe try to figure out how someone made our hull shape or the wing shape. Who knows? There's so much things you can do, and this might be something you might have to do for at least rest of your university courses. At least I'm using it for capstone for sure. So yeah. So things to try for GrabCAD stuff. Workbench desktop app. It's just very nice and easy to use. You could also try the GrabCAD mobile app. For the part files or like the revisions, versions that GrabCAD supports, you could see the parts on mobile, but I know it's a bit finicky. So like if you really want to show off a part that you've been working on to like your friends or your family, but you don't want to like open up your computer, I guess mobile is the way to go. And yeah, if you have anything that you find pretty cool, please let us know and we'll try to like share it with the team. And yeah, last but not least, again, special thanks to SolidWorks for supporting all UBC engineering design teams. They provide us with like the licenses that allows us to do simulations, and also the exam codes for CSWA and CSWP, which kind of like certifies you that you know how to use SolidWorks. So those are kind of nice things to have, I believe. So yeah. I'm just gonna double check if there's any questions from the audience on either places. Nope, I don't see any questions. So think I'm gonna end our stream now. It's pretty late. Thank you for sticking with the long tutorial today. I know everyone's busy with midterms and assignments and all that fun stuff. So I hope you good luck with your school, and hope this was helpful. And please give us feedback. Give me feedback. Just like message me or just leave a comment in the announcement if you have any suggestions, any other topics that you want to be covered, and such. And I'll try to work on the slides based on if anyone have feedback from today. I just wasn't sure what would be useful for everyone to know, or like what level of knowledge everyone has when it comes to drawings. So that's why I kind of just like showed how I would do stuff. But yeah, drawings get more interesting if you have more complicated parts, I feel like. So yeah. Anyways, have a good night or good morning to you. You feel so enlightened. I'm happy you're very enlightened. You feel enlightened. I did something, I guess. Alright, I'm gonna end my stream here and see you guys on Saturday. Alright, I'm gonna end my stream here and see you guys on Saturday.